So your grades will always show up on Blackboard, but for those of you who are here, if you've been missing a lot of classes, you're going to get an unsatisfactory because they're going to drop you. Because this is a virtual class, which means you're supposed to be attending, or you make up for it when you don't. So technically, you should have those notes right away. But this is not an online self-paced class. The test is coming up. You see my screen? You guys, did I share the screen?
No.
No.
Okay, well, let me share the screen. Under your test folder. Let's see what it says here. So there's two parts of this test. One, let me just edit the test options. So you will have a 90 minutes to complete this test. Okay. Now, if you have a blue card and you're supposed to get extra time, it's just going to say late. So you don't have to worry about writing to me, just turn it in. If I feel that there's a problem with people abusing the time limit, I'm going to talk to you about it because everyone else should take 90 minutes. I am going to display this test for you, and it might need to go into this month. I think what I'm going to do is I'm going to, let me see, we meet on Tuesday, Thursdays. So I'm going to display the test after class on no, you know what I'm going to do? I'm going to display it starting tomorrow at 7 o'clock in the morning. Okay, and I will display the test through Sunday at 11:45 p.m. Oops. Let's try to do this. This didn't seem to be the right time. The 20th. Okay, so what that means is the test will become available. Once you start the test, you have to finish it. You can't just come back to this part of the test for a period of time. So it's going to force completion. It means once it started, you have to do it in one sitting. The test will be made available to you. You get one attempt. When you submit your answers, they are there. These things are going to be multiple choice, and a few of them are fill in the blank. So you got to spell correctly. I make it so it's relatively easy. It's not going to be that upset by you, but if I'm asking for something important like nitrogen, let's say, and you're spelling it NXPHY, whatever, it's not going to work. Okay.
Oh, yeah.
So that test will be, this will show up available for you starting on Wednesday. So if you have any questions, you can do it. I would suggest that you do it over the weekend and wait till after. Actually, you know what I'm going to do? I'm lying. I'm going to change this. I'm going to make it. Hold on. This is in my way. I'm going to make it available after class on Thursday because I don't want you to do it before Thursday. So sorry, I lied to you about everything. I'm a terrible lying to you. So you'll have from Thursday after class at 3 p.m. and you'll have through Sunday. Does that make sense to you? So you'll have Thursday afternoon or Friday or Saturday or Sunday to do the test. However, we also have an essay portion of the test. Okay, and this essay portion of the test, I'm going to make available for a much longer period of time. So it is due, it will be due Sunday, just like the other part of the test at, how do I do this? End of the day. Okay, and it will be available. Where is it? I will display it. Oh, you know what? I'm just going to make it available. So what I would suggest you do is you can use after class tomorrow, you can open up this test, the essay portion. I would say do that first because it forces you to do much more complete work. Okay, so it's open notes. Everything is open note. You have to work individually, but it's open note. And because it's open note and because it's essay, I'm expecting super high quality work. So I expect it's all to be typed out, include diagrams. Listen to me, I've told you this before in the notes, include diagrams. You cannot do too much to answer these questions. You can do too little. So you can read through it. If you have a question, you can talk to me about it in email. You can talk in class on Thursday. All I'm asking you is you do everything individually. But if you use that essay to do first and then use that as a study mode, that'll help you when you get to the multiple choice, which is more objective. And that will be the same as we go forward in the other tests. Does that make sense to you guys? Do you have any questions on just about the test?
No, sir.
Oh, there's Ian. Hey, Ian, where have you been, bud?
Yeah, sorry, I had to shovel today, or make sure that the gate was like actually shoveled so it wouldn't just get blocked up when the car tried coming in.
No, I have you gone from last week.
Oh yeah, that was a kind of wacky week going on.
Okay, so I was telling everybody else that if you look online on Blackboard, you will find all those absences. I need those notes sent to me so that you get the points back for the absences.
All right, yeah, I'll get that to you as soon as possible then.
Okay. And do a good job. So that's what's going on with the tests. Are there any questions on the test? Do you understand completely? Aaron, you and your dad, we've sent emails. You're all good to go. And you can do it just at home. That should be fine. Anything else, please? Speak now, forever. We covered most everything. We have a few little things that maybe we need to go through today, plus station models. So I'll let you know when we go to the next unit. We're just going to keep going, but I'll tell you where the ending point is. Do you have any questions over any material that we have done so far?
No.
Nope. I mean, this is really the chance to ask me. Any comments from last Thursday's notes on the greenhouse effect and global warming? I could talk about that for long periods of time. Hey, speaking of which, I have to bring this up because we were just talking about this. You know, we mentioned something about the XL pipeline, and you know, we talked about this. And as a result of a lot of policies, Sam, we were talking about this, a lot of policies where people are going to renewables. Have you heard what this storm did to the renewables? Like, did you hear what's going on in Texas?
Didn't like Texas and New Mexico have a power outage or low on power?
Like 2.5 million people are without power in the midst of the worst winter storm and record cold temperatures. And Kansas is rolling power because they can't generate enough power. Do you know why? Because they are relying very heavily on wind power. You know what the windmills have all done?
Frozen.
They can't work. You can't generate power into the grid. So without having backup, without having the ability to switch over and generate peak demand power, it's kind of a dangerous situation. So now there's going to be people dying of freezing because their houses have no power and there's no heat. So renewables are answers, but they're not very good answers all the time. They're supplemental answers. Did you see those pictures, Sam, of all the windmills frozen in place?
I have not, but I have seen the how all Texas is under a winter storm warning.
It's amazing stuff. This has been an unbelievable storm. Did you hear what happened? How much snow did you guys get? Shannon, how much snow? When was the last time you've been outside?
I think like 2 inches, 2.5 maybe.
Where are you
It was snowing for a while.
Where are you?
I'm in Downers Grove, so
You got more than that.
yeah.
Downers was coming in at like, most of DuPage County was 6 to 8 inches of snow. Sam, what has the weather been like up where you are? He's up in Madison.
It's just been frigidly cold. It hasn't snowed much from this system.
But you've already got snow on the ground, right?
Yeah, we have almost like 1.5 feet.
So Chicago O'Hare, if they get snow, measurable snow tomorrow, Wednesday, will be 10 days in a row of measurable snow, which sets an all-time record for O'Hare. And it looks like they should get snow tomorrow that's measurable. And there's also a good chance that they're going to get it on snow. So they're going to break records with this. We've had, I think the thing is, as of Sunday, we were 5th all time of 11 inches or more snow on the ground. And I believe O'Hare is going to be somewhere around 18 to 20 inches on the ground. And it's not going to go away until start to melt maybe Monday. So we're talking about near record categories for length of time with snow on the ground, the amount of snow on the ground. This is an incredibly cold, horrible winter. Lena, you like it?
I
Still
feel
loving
like
it.
You're
I feel
not
like
in
last winter
agreement,
we
but I'm not
didn't.
sure that you like this kind of stuff. How are you
I
guys
don't.
surviving with it?
What?
How many of you have been out shoveling?
I have.
Ian, what you been up to? Talk to me about what you've been up to.
Just lots. It's like been shoveling like every other day. It feels like, and I don't like it anymore. I like the snow, but I don't like shoveling.
Yeah, it's like every day you're shoveling, and we have snow in the forecast for the next 3 or 4 days. It looks like maybe next week the snow comes out of the forecast, but
Would this be, is it El Nino?
this is a
I
La
forgot.
Nina winter.
Okay.
The funny thing is, Shannon, I actually have done a lot of work on long range forecasting. And one of the things that was interesting to me is I was watching the pattern in December going, we're going to have a really boring winter till mid-January and then look out. And sure enough, we have gone, and right now, Chicago's had 45 inches of snow already for the year. The average is like 37 for the entire year, and we still have all of March to go. We could be at 50. I mean, it's possible we could get 60 inches of snow, which will put us in the top 5 of all time. So I think this is a crazy winter. I don't see the end in sight. Maybe next week in the long term it starts to moderate, but it'd be a whole lot easier if you were further south. I am right now in Florida. Oh, I got Sam, I'm gonna make you jealous. How do I switch my camera? How do I turn it around? Well, I'll have to do it this way. But I want to show you all something because I know you're jealous. But there's the anvil of some beautiful thunderstorms. Can you see that?
Yeah.
And there's the ocean. And it's sunny right now, but so I've actually had some thunderstorms going on today. There was actually some funnel clouds reported somewhere near the area, not here. I was looking. So Sam, there's convection for you, buddy.
There was some really nice storms to the north yesterday. Of you.
Did you guys hear about the tornado that went through North Carolina? 3 people died. So yesterday, not only did we have all these big ice storms and snowstorms, we also had tornadoes. So it's been pretty active.
Some pretty nice looking supercells on radar yesterday. Really impressive.
That's awesome. So it's been a very active season. We're starting to go into spring. So that means the deep south, after it gets through this ice age, basically. I mean, we're talking all-time record cold temperatures in Texas going below 0. Parts of Abilene, Texas had what, 14 inches of snow? You know how far south that is? Right now, it's the most I've ever seen. 73% of the United States is covered in snow.
It's the end.
73%. And I've never seen anything like that. So when it's over 50%, it's usually like, wow, but 73% is crazy. So you're living through a historic winter storm. So even though it sucks, you can go back and remember how horrible the winter when you're locked in your house of 2021 is. And hopefully we'll get like record April warmth. That would be nice. I could live with that. Anyway, let's
Only
move.
hope now.
Unfortunately, you know what I lost, and it fell out of my bags during like I had to pull something out because they told me I did. I lost my Epic pen. So I have no more Epic pen today. So I'm going to have to do this. Am I sharing my screen?
Mhm.
So I'm going to go to minimize you guys, and I'm going to go to here. Oh, I can't. No. I have to go to Paint. And I'm going to do new, and I'm going to just draw a diagram here. 2D shapes. I can draw circles. And so when I'm doing a station ob, I start with the circle representing the station. Now, what do I do with this circle? So if you have your information on this, you need to, talk to me about it. What's inside the circle?
The circle is usually shaded or non-shaded or partially shaded depending on what the weather and cloud formation is.
Yeah, really based on the amount of clouds. So if it's open like this, what does that mean? It means it's clear. If it's completely shadowed in, what is it called?
Overcast.
Overcast. Okay, there is something that you need to know. And if I do this, not the easiest way to draw lines, but if I draw an X on it, man, I miss my Epic pen. What does that mean?
The sky is obscured.
What does that mean for the sky to be obscured? And that's certainly something you need to know. What does obscured sky mean? I think that was you, Isaac, wasn't it?
Yeah. My guess is that it would just be really hard to tell what's going on in the sky. Like there's just quite a few things going on. I'm not sure.
What would cause you not to be able to see the cloud cover of the sky? And don't say night.
Would there be fog or
Your
steam?
number one thing is going to be fog, right? If it's foggy out, you can go, a little bit above the fog layer and actually have no sky clouds whatsoever. So fog is a very common, what we call obscuration. What else besides fog? And it was probably true last night in Chicago.
Could it be like blizzard conditions? Like if the snow is blowing so hard, you
Okay,
really
so-
couldn't see far?
If you have blizzard conditions where the snow is blowing, I've been in situations where the snow is blowing from the road so much that 15 feet above the ground, it's totally clear and easy to see. But from the ground level, you can't see anything. So zero visibility. So blowing snow, even if it's falling, a lot of times it's falling snow. And those of you who are in aviation, right? What I'm caring about is if it's snowing really hard, that might mean that there's a cloud overhead, but I see a long way on the horizon into the sky. And so if I'm not seeing that, then that becomes a problem. So when I get to a sky cover, here's the words you need to know. Clear. Actually, let's do it from full to nothing. So we start with overcast, and then we go broken, which is like 5/8 to 7/8, to scattered, to, you may see this term, few, and then clear. And then I'm also going to say obscured. Okay, so I've got overcast, broken skies, scattered clouds, a few, meaning there's a couple of clouds here and there. It's not, we usually they measure it in terms of eighths of the sky being covered. So a few is not like even covering an eighth of the sky, it's just some clouds around. And then clear. So those are the words that are going to be used, especially in something we call the Metar, which is a meteorological airway report. And it tells you, it'll give you those words, and I'll show you that in a second. But for now, that's just what you need to know, those 5 words, and then obscured. So those are the things that obscure. I suppose smoke could obscure the sky. Whatever says you can't do it, that's going to be the case. So I go back here. I'm going to undo those 2 things because I'm not going to shade this in right now. To the far left, I get visibility. So if I said 3, for instance, I guess I should cut and paste that, yeah. If I put it in there, that might be 3 miles of visibility. So that's a horizontal visibility, far to the left of the station. And what's to the immediate left? What goes to the immediate left is a symbol for current weather conditions. Now, unfortunately, I usually would write these out. So you have this in your book, but I can go online and do this as well. So like when you're doing notes, right, it's easy to do that. So if I go weather symbols, that's pretty straightforward, right? And so I'm going to go into one that has this one. It looks like it has the most. And I'm just going to point out a few of them as we go there. Okay, so how to read symbols on the maps. Seems like a good thing to have. There we go. So by the way, there's your sky cover. If you want to be in more particular, I'm not going to ask you for that, but those are the ones that you need to know. I mean, that's what I mean by the 1/8 of a cloud. But here's this diagram. And is that clear enough for you to see this? So the ones that you want to know are going to be this. You don't need to know all 100. But if you see dots, like this one here, dots means it's raining. So the more the dots, the heavier the rain. Now, rain is usually what we call a continuous weather feature. So you should write that down. Rain would be continuous. The same would be true of the asterisk, which is snowfall. So that would be continuous snow. The comma is what we call drizzle. Now, do you know what a drizzle is? What's drizzle?
Like really, really light snow. I mean, snow or rain, yeah.
Well, no, light snow is still snow. It could be light rain, but it's not just, what do I mean by light rain? Like, do you know how to separate what drizzle is versus rain? Zach, how about it? What's the difference?
Would it be like how big the droplets are?
It's exactly correct. How big the droplets are. Drizzle doesn't really have, it's falling, but it's not really going to collect. So if it's drizzling, you're not going to measure more than what we call a trace. Raindrops will eventually pile up to create equivalent of water. So drizzle is just really small drops. Now, despite just doing it for this one, we are eventually going to talk about drizzle in terms of weather patterns and why it's so important. But for now, that's what you need to know. Okay, good. Wait, where were we? We're on this one. All right, now over here, see this, the triangle with the dot on top, or it could be a triangle with the snowflake on top. That indicates showers. So a rain shower or a snow shower. And there's all sorts of ways to talk about the intensity of it. That's used, at least it was more in the past. I don't see it used very often, but a shower means it's coming from a cumulus cloud. Have we talked about instability, guys, in this class? Yes or no? I need somebody to talk.
No.
Okay. We've talked about parcels, right?
Mhm.
So if I took a parcel of air, and this is a good review. This is the hard part that you need to know. If I lift the parcel, what's the first thing that happens to it? Everybody unmute their mic because I want it to be a fast conversation. This is a review. What's the first thing that happens to it?
The pressure outside the box decreases.
Second thing?
Pressure inside the box decreases.
Yes. And Aaron, here's a question directly for you. When is the pressure inside the box equal to the pressure outside the box? We'll let Aaron answer. All of you think of the answer. What have we got, Kevin?
She says it's in equilibrium.
It is, but the question, and I'm saying this for a reason, when is the pressure inside the box equal to the pressure outside the box, outside the parcel? What's the answer, everybody?
Always.
The answer is always. Now, technically, it can be different and it seeks to change, but the answer for the parcel, for parcel theory, is always. So because the pressure decreases, the pressure inside has to decrease. So what is the box doing in order to decrease the pressure? It's expanding. So the first thing that happens, the pressure goes down, then the box expands. And when it expands, it does what? What else does it do besides expand?
Cools.
How much does it cool?
10 degrees Celsius per kilometer.
What's that called?
The dry adiabatic lapse rate.
Okay. Now, we probably didn't mention much about dry adiabatic. What does the word adiabatic mean?
No heat, right?
Okay, so dry adiabatic means no heat. Dry, or I'm sorry, the word adiabatic means no heat. Dry means, well, it means that you're going to be what? What does it mean to you? Have we talked about that? I'm not sure if we've talked about that per se. What does the term dry mean?
Is it lack of moisture?
In what way? How would I define that? Because moisture is our next section. That's what we're going to be getting into.
So like lack of water specifically?
When you say water, what do you mean by that? I'm going to be really specific here.
And this water vapor?
Okay, so what's the first fact about water vapor you need to know? Now, some of you have in my other classes, so you should know this one. What's the very first fact of water vapor?
It's invisible.
It's invisible. Okay, so if I said dry, it doesn't mean that it's invisible. What it means is it's not in a cloud. There's no cloud in the box. Now, the cloud in the box says that the air is saturated. Saturated, have you heard of the term relative humidity? If I said relative humidity, what do you think the relative humidity is when the air is saturated? Everybody?
Relative to the temperature.
Well, what's the value if the
100.
air is saturated?
100%.
It's 100%, right? If the air is saturated, the relative humidity is 100%. And if the relative humidity is 100%, we are saying that we have a cloud. So we are saying that in a dry adiabatic ascent, inside the parcel, there's no cloud. Eventually, there will be a cloud. That's what we're going to be getting into. Okay, so the point being is you're lifting the air. It's eventually going to reach this thing called saturation, where there's a cloud that forms. But here's the other question that I need to ask you at this point. As I lift the box and I let go of it, what happens? We have done this before, yeah? So what's going to happen?
Gonna fall?
Does it always?
No.
It could do what?
I'm not sure.
What's the other answers? Ryan, what do we say?
could go up or stay the same height.
Okay, so it could do those things. If it goes up after I let it go, what's the reason for that, Tom? Like I lift the box up, I let go, and it starts rising by itself, right? I'm not pushing it up anymore. What's the reason for that?
It would be that it's less dense than the rest of the atmosphere.
Okay, it would be less dense, and really, I wouldn't say than the rest of the atmosphere, but I would say than the air around it. And when I say the air around it, what am I referring to? Which way around it?
The way around it,
No,
above and below it.
no. Outside of it horizontally. So
Horizontal.
I'm always comparing the air to whatever it is outside so that the pressure is the same. Because going up, the air is less dense. So that's always kind of the case. So what I'm saying, it's less dense than the air around it on the same level. And therefore it's buoyant. Now, if it's rising by itself, do you agree that is unstable air? That is buoyancy. I think we've talked about this. Less dense than the air around it. But if it's in the cloud and the air rises by itself, that's what we call a thunderstorm or a cumulus cloud. Actually, let's just go that way. If the air is in a cloud and it rises by itself, we say that that is a cumulus cloud. And if a cumulus cloud produces precipitation, that's known as a shower. Does that make sense? That's where we get showers. So when I go back to the weather symbols and I'm looking at this thing here, and I'm like, oh shoot, where is it? And I'm looking at this symbol here, that means it's raining. And the reason it's raining is because it's a cumulus cloud. And if it's a cumulus cloud, we call it a shower. So technically it's what we call a cumulonimbus, because nimbus or nimba refers to precipitating. This is what's different than rain coming from not. So I could lift the air and keep pushing it high enough so that it produces precipitation. I can make the cloud by forcing the air to rise, but it's not rising by itself. I'm actually lifting it, and that would be a stratus cloud. So what kind of precipitation falls from a stratus cloud? Continuous. Rain or snow or drizzle. And what do you call a stratus cloud that is precipitating? What do you think? What? See? What's Aaron got there?
I'm not sure.
Julia, what you got? What do we call a cumulus cloud that rains?
Cumulonimbus.
What do you call a stratus cloud that rains?
Stratonimbus.
Okay, you would think stratonimbus, right? But it's not. I don't know why it's not. I didn't make up the rules. It's called nimbostratus. Now the nimb becomes the prefix, not the suffix. I don't know why that is. So it's a nimbostratus. So yesterday it was snowing. Most of those clouds were nimbostratus. But do you hear what happened out of Chicago? You actually pulled in air off the lake, which became extraordinarily unstable. And there was a report. Did you hear what happened near Midway Airport yesterday? Do you know how much snow they ended up getting? 17 inches.
Jeez.
They were getting 3 inches of snow per hour.
Would that be considered a convective burst?
Well, those clouds, when you have a lake effect snowband like it did, Sam, that would be considered cumulus. So coming down to 3 inches an hour, that's crazy amount of snow. We would consider heavy snow to be 4 inches, 1 inch an hour. So if you look over here, see this? Where it says continuous fall of heavy at time of observation. The 4 snowflakes. That you're looking at about 1 inch an hour. And this was coming down at 3 inches an hour. I've seen Albany, New York that had 4 inches an hour, which is about the most I've seen outside of mountainous areas. But that is extremely heavy snowfall. By the way, when you get to extremely heavy snowfall, guess what that does? It lowers the visibility. So heavy snow is going to be very low visibility. Heavy snow will be very low visibility. In fact, we determine snow by the heaviness by the visibility. So heavy snow is less than a half a mile visibility. And evidently yesterday in Chicago, you could not see a city block. That's extraordinarily heavy snow. Anybody else have heavy snow yesterday? Were you anybody in one of those snow bands in class?
No, we rarely get lake effect here.
No, you don't. We don't get lake effect that often in Chicago because usually the cold air comes in out of the northwest. So it goes to Indiana and Michigan. But yesterday the winds were northeast with really, really cold air, and they get up some amazing snow bands. So we don't see that in Chicago often, at least for prolonged periods. But if you think of yesterday, I mean, did you expect there to be 17 inches of snow in Chicago? That's why over here in DuPage County, it's more like 6, 7, 8 inches of snow. Anyway.
Actually, we had lake effect snow once, and that was a couple of years ago.
Yeah, every once in a while you get something cool. Anyway, that's the difference between those snow types. Okay, other ones that you need to know. See this guy? This is what we call a thunderstorm. Actually, if you look at this symbol here, it's got a little arrow, so it's like a pointy R with an arrow. So look at number 95. That's a good idea. And that is that's the symbol for thunderstorm. And you could have thunder snow. That's kind of cool. So if you look at the details of this, now how many of you folks are going to be doing aviation? Abby, I know you are. Zach, did you say you are too? Oh, Abby, who else? Just you, Abby? I thought there was somebody else in the class. Okay, well, anyway, you might have more detail about what heavy snow means, okay? So be aware of this sheet. I don't think any place will have you memorize all of them, but you'll get to know them. Now, this thing here with the little wiggly line and the dots is freezing rain. If you have one dot, it's slight freezing rain. This is moderate or heavy. You could have freezing drizzle with the little commas in there, but that little symbol, that squiggle, is freezing precipitation. And that means it's falling as liquid, and then it freezes when it comes in contact with the ground. Okay, falls as liquid and comes in contact with the ground. Now, the other one that you need to know is this guy over here, number 79. So that's the symbol for sleet. And sleet are what we call ice pellets. So that's little chunks of ice. You know, no, little chunks of ice. You gotta say it with Southern accent. That's the way it works. Okay. Any questions on those so far? Now, if I look over here at horizontal lines, and there's all different ways of drawing it in, but horizontal lines basically mean fog. You might see mist over here. So Abby, something you need to know is that mist is an obscuration to visibility where it's bigger than 3 miles, and then if it's less than 3 miles, it's called fog. Something along those lines. Mist and fog are the same as far as you're concerned. Okay, so those I want you to know. Now, these you don't, well, here, one more. I want you to know this symbol, which is haze. The infinity sign is the symbol haze. Those are the ones I will test you on. This one is cool. This is smoke. So if you're a pilot, you probably ought to know smoke. Dust, the dollar sign or the S is sand or dust. Remember, these are certain types of things called meteors. Now, just for a second, I want you to go to your notes from the class. Can you go to your notes from your class and define what a meteor is? Can you read me the definition of meteor? Ryan, go ahead. Do you have it with you?
No, I don't think I wrote it down.
Well, no, these are the notes from that I gave you for Unit 1. Because the thing is says, what is meteorology the study of anyway? So meteorology, we're studying meteors. So what the hell is a meteor? So is anybody there? Zach, you got that?
I'm pulling it up right now.
If you see me looking out this way, it's because, Sam, I don't know, can you see this? Can you see the beautiful cumulus tower? Speaking of cumulus and thunderstorms, you see the big thunderstorm that's developing out there? You can, do you guys see this okay?
So
Yeah.
pretty.
No.
So you can see where it's starting to form precipitation. So that's a cumulonimbus. There's even a sort of a cloud base lowering over there, Sam. That's the base of the updraft a little bit. It's not moving too much, but there are some thunderstorms in the area. There's a tilt to the updraft, which tells me there's some shear. Lena, you remember that from last semester?
Yep.
So I'm just kind of looking at this thing developing, and are we in a moderate risk for severe today, Sam?
No. Where are you again?
I'm in Southern Florida.
But where?
I'm looking at.
There's a lot of those are actually special marine warned.
Hold on, I want to show you guys something. If I go to the Storm Prediction Center, yeah, there's no risk down here, but we've got general thunderstorm risk down in this area, so I can use radar. Let me go here to show you this. And I'm going to pick a place to go look at it.
This is going to be a spout day.
Yeah, there were some reports of water spouts this morning. So I'm down over here. And so there's some this is the thunder I'm seeing off to the southwest. So there's thunderstorms kind of moving my direction toward me. I guess I'm up a little bit further, maybe here. And there was a good line of storms came out this afternoon. So we use radar. So that's a cumulonimbus cloud, right? So that's the kind of stuff that we're looking at. Okay, so what does it say about meteor?
It's a phenomenon other than a cloud observed in the atmosphere consisting of precipitation, a suspension of liquid or frozen water or other particular matter, or an optical or electrical manifestation.
Okay, manifestation, something that manifests, that shows up in the sky. Now, there are 4 types of meteors. One of them is a hydrometeor, hydro meaning water. The second one is a lithometeor, meaning solid. Remember, these are not clouds. We're not talking about clouds. The third one is a photometeor, which is light. So rainbows. We're going to go into the detail. I'll show you pictures of those. And then the last one is electro, so electricity. Now, these symbols are showing you observations primarily for weather observers. People go, what's the weather? So when you're looking at the station model, this is going to go to the immediate left into this space right here. You're going to draw in something. So if I were to draw in something like this, I would say there's a rain shower. Okay, so that's the shower for the symbol with 3 miles visibility. So since we're observing events, These are what we would see as almost always hydrometeors: rain, snow, sleet, freezing rain, blowing snow. But because we're talking about smoke and dust or ash, even a dust storm or sandstorm, these are also lithometeoric events. So smoke and sand and dust, those are what's going to go on from as a lithometeor.
What would a hail count as?
Hail would be, I'm not going to make you know this for a test, but hail is a little triangle up on top. So on top of the thunderstorm, because hail is going to be associated with the thunderstorm, because it's liquid or frozen water, that would make it a hydrometeor.
All right.
Okay. Now, here's the thing about it, though. Sometimes it says, or a suspension. Okay. It doesn't dust out, right? Things don't fall from the sky. Dust is kicked up by the winds. So this is a suspension of liquid or solid material. And you can do the same thing when it comes to dust storms or drifting snow. I think some of you said the winds were pretty bad yesterday, and now we've got blowing snow. That would be this symbol here. And again, I'm not going to test you with this guy, but if I saw those little arrows, that's the kind of thing you'd have to look out for. So you're a pilot, you better know these if you see a sign going, oh, it's windy there, there's snow blowing up, I may lose sight of the runway in my final approach or something. Okay, so Abby, you'd want to go to, do you know the difference? Do you know what IFR and VFR means, Abby?
No,
Anybody know
sir.
what VFR is? You ever heard of that term?
Visible flight restrictions.
It's visible flight rules. In other words, if you're a pilot, beginning pilot needs to be able to see the ground, and they can't fly through clouds. They can't fly through zero visibility. It's called visual flight rules. Once they're experienced, they have to trust their what? What they can fly blind by looking at their what?
GPS.
No, God, not GPS. You use your instruments, because you got to know which way your airplane is, you know, artificial horizon, that kind of stuff. So you're trained to fly without visibility. But even the best pilots need visibility down to the ground. They can't fly in zero visibility. So if you're going into an airport, there's times where you get major backups because the visibility is so restricted, they're not allowing planes to land, or they're canceling flights. So, Midway Airport yesterday got shut down because there was zero visibility with the heavy snow, and they couldn't land in that kind of snow. So it was pretty dangerous for pilots. So they care about the details of something like this. Okay, and I think that's all the symbols that you need to know. Okay, so you got those all okay, guys? Now let's go over here. What goes to the upper left? And the answer is
Temperature.
the temperature. So I'm just going to put in here, I put in the temperature. Oh, that's a little too big, isn't it? Sorry, let me just redo this. So the temperature is 54 degrees. And then what goes on into the lower left?
Pressure.
Dew point temperature.
It's called the dew point temperature, okay? Now, we haven't defined what the dew point temperature is, but since we are playing the game of going into the next unit, let's define the dew point temperature while we're in class. So, do you have access to your Unit 2 notes? So go ahead, and what does it say for the dew point temperature? So you can mark Unit 2. You need to know the lower left part is the dew point, but what is the dew point temperature? So let's take a look at that.
It says the temperature to which air must cool at constant pressure in order for dew to form.
That's what you need to think about. It's the temperature to which air must cool. The most important 3 words is at constant pressure in order to get dew to form. And dew forms when the air is saturated. In other words, you're getting clouds. Now, dew forms on objects like grass blades or your car. But if you said air temperature drops to the dew point in the atmosphere, you're saying that you're going to get fog or a cloud. So you get fog when the dew point and the temperature are the same. The air is saturated. Okay, so that's what the dew point is. It's in essence, and Ian, we kind of alluded to this, it is a measure of the moisture of the atmosphere, how much water vapor is in the air. It measures that, not directly. We'll find a better term for that, but it does tell something about it. So right now, back at home, what is your dew point? I'm going to go here. What does it say the dew point is?
10 degrees Fahrenheit.
10 degrees Fahrenheit. The temperature is warmed up all the way to 17, which means if the temperature were to cool at constant pressure to 10 degrees, the air would become saturated and you'd start developing fog. The dew point is an indication of how you feel. Now, would you agree that your skin is probably super dry? I mean, it's when the dew point's in the single digits and it's been below 0 for a week. And now it's gone up to 10. Woo-hoo. Wow, crazy, right? It's still really dry. You like dew points in the 40s or the 50s. So your body, if the dew point's in the 40s or the 50s, you start to go, that's fairly comfortable. When the dew point gets to be 60 degrees, that's when you start saying, and it doesn't matter what the temperature is, it's what you start saying, oh, it's really humid out. See, we don't want to use humidity. That's a bad way. We're going to find that out. But dew point of being in the 60s, you're like, oh, it feels really humid. The dew point here where I think it's around 67, 68. So it's very humid. I walk out in the morning, it's very humid. And I'm telling you, my skin feels so much better with this humidity. But you would be uncomfortable. If you get dew points in the 70s, that's when you start going, oh, it is really uncomfortable. Nobody likes dew points in the 70s. It's sweltering. It feels awful. Nobody likes it for feeling. Sam, you might like it for storms. Technically, I don't. Why do you, by the way, Sam, why do you think I don't like dew points in the 70s?
Well, I think it might be too much, too high.
For what reason?
Oversaturation.
Nope. No, it's thunderstorms like dew points in the 70s. Absolutely. I said I don't like dew points in the 70s. Why?
Oh, you personally don't.
And the reason for it is when the dew points in the 70s, the sky becomes harder to see through because it develops haze. So that little symbol haze is what happens when you start getting dew points too high. Now, what is haze? Do me a favor and just do a quick Google, define haze. What does it say?
Just suspended particles in the air that causes low visibility.
Suspended particles of what? Usually. Does it say? Anybody see what it says?
Dust, salt, aerosols, or smog.
See, okay, so that's kind of true. But the other thing that happens with haze, so like if you have pollutions in the air, you can say, oh, it's a hazy sky. But what's happening is water vapor is collecting onto it because those particulates are serving as what? Listen to what I said. The water vapor is condensing onto those particulates because they're serving as what?
Is
It's an acronym you need to know.
CCN.
CCN.
It's-
They serve as CCN. Did you get that, Aaron? Were you going to say that?
Yep.
Okay, good. Hey, Aaron, you know what you can do if you think you know the right answer and you want to answer that, just kind of just say the word as best you can, and then your dad can you can spell out the letters for him, and this way I know that you've got the answer,
Okay.
so that you can just be loud and we'll all listen. We'll wait for you, okay? So that serves as CCN, and so what's happening, and this is kind of a fun thing. I've been teaching meteorology, and I know what a hazy sky is. It's hazy, and I never thought about beyond, oh, it's hazy. And then some astronomer said, hey, can you give a talk about visibility for astronomy? Because, they're trying to see stars at night. So I did some research on haze, and there's two types of haze. When it's really polluty, is that a word? Can I use that word?
Mhm.
There's a lot of pollutants. You get smoke or ash or factory crap. It turns into sort of a brown haze. So whenever you land into Los Angeles, anybody ever flown into LA? It feels like you're landing on a cloud of brown. It's gross. And you can actually see the brown laid over the city. That's haze from pollution. But you can get blue haze when it's just water vapor in the air. Because what's happening is when the air saturates, water vapor turns into liquid. And we say that the air is saturated. But the problem is at lower relative humidities than 100%, like 75, 80% relative humidity, water vapor turns into liquid. But because the air is not saturated, what does the liquid do? It evaporates. So it's like kind of going to liquid, and then it evaporates and goes away again. But because we're looking through it, there'll be times where the water is there turning into liquid, and then as it goes away, and it's happening all over the atmosphere. So rather than seeing a cloud, our visibility is obscured. And so that's what haze is. So when the dew point's high, that tells me there's a lot more moisture in the air, and we're going to run into a lot more haze. And haze restricts visibility. I've been out storm chasing on dew points in the 70s, and I can see maybe 2 miles. Do you know how hard that is to spot a tornado when you have to be within like a half a mile in order to see it? You need some visibility so that you have an idea of what's going on in the storm. So that's where haze plays a role. But in any case, going back to this, there's my symbols for temperature and the dew point. Okay, now the next thing we have is to the upper right corner, and that what goes there?
Pressure.
Pressure. But it's a 3-digit number. So what do we do with that?
You round up or you round down.
Well, no, it's not rounding. Like if I see the number 014, what do I have to do with that number? What does that represent? What's the unit of pressure in the atmosphere? What's the unit of pressure in the atmosphere?
Would it be hectopascals?
Yes, Shannon, I am annoyed because I'm an old person and I don't ever want to use hectopascals. So unless I have to, I'm not going to use hectopascals. What's that equivalent to? What's the
Millibar.
Millibar, something called a
Millibar.
millibar. Okay, so, and what did we say our standard sea level pressure was?
1,013.25.
That is the number you need to know, 1,013.25 millibars. That's if we averaged it up, okay? So it's going to be somewhere around 1,000 millibars is what our standards, our pressures are going to be when we're measuring it. So what does this 014 mean? How do I convert that over to millibars? Well, the first thing you do is you put a decimal point before the last number. So let me go over here. So if I saw 01, whoops. if I saw 014, is that the way you spell obscured, or did I spell that wrong? One R in obscured. Oh my gosh, what's wrong with me? If I see 014, the first thing I need to think is it's something 01.4, and then the answer will be given in millibars. So when I see the 3-digit number, put in the decimal point. Then what it is I'll either add a 9 in front or a 10 in front. I either put a 9 in front or a 10 in front, whichever makes it closer to 1,000 millibars. So what's the answer? I put the 10 in front. It's 1,001.4 millibars. Does that make sense? Say yes or no.
Yes.
Yes.
Okay. So let me do this one. If I saw the number 213, what's the pressure? What's the answer, guys?
Is it 921.3
Millibars.
millibars?
Are you saying you put, no, which, is it 921.3
Yeah.
millibars? And you gotta say millibars. Is that what, do you all agree?
No.
Yeah.
What do you say?
1,021.3.
Right, because 1,021 is still closer to 1,000 than 921. So the answer would be 1021.3 millibars. So do you see that?
I would have thought 992.3.
No, you just got to be careful. You got to know how to do this because I'm going to give you this on a test. How about this one? If I saw 898, convert that or decode that, is the correct terminology.
989.8 millibars.
So it's going to be something 89.8 millibars. And then is it, you either put in a 9, so it's either 989 or 10, which is closer to 1,000, 989. So 898 would be 989.8 millibars. And that's the way you do it. So this would be 1,001.4 millibars. You just have to remember the mechanism to find that. And I'm going to ask you this on a test. Pretty straightforward. It should be relatively easy to do. Okay. Now, sometimes you can have, do you understand that at 50, 05 or 500, 500 would be, well, which one is it? Is it 9 or 1,000? You could have pressures greater than 1,050 millibars. Not very often, but it could happen. And then you'd be in the middle of really high pressure. And you just have to realize that I'm in the middle of high pressure, so I know what that would convert to. And if it's under 950, under what conditions do my pressures drop below 950? Like, when does that happen? What do you think? Under what conditions would the air pressure be less than 950 millibars?
Would it be during low pressure thunderstorms? Maybe?
Not a thunderstorm, but do you agree it would be under really low pressure?
Mhm.
So it would be a really big, large scale storm. What's the most common storm to knock pressures below 950? Really, they drop really low, like 950. I've seen 920. What kind of storm does that, though? That doesn't happen around here.
A hurricane.
Hurricane.
That's where a hurricane is. So again, if you saw 300, you would say, oh, that's 1030.0 millibars. And really, if you're in the middle of a hurricane, it's 930.0 millibars. But if you didn't know you're in the middle of a hurricane, you're crazy. And now it is pouring rain here. No, is it raining out here for me? What's it doing outside my window? Okay, what is this? Oh, sorry, that's the wrong way. What is that outside, folks?
Can't see it.
You can't see the precipitation?
No.
Well, it doesn't matter. It's precipitating. It's hard. But what's going on outside my window right now? This is the test question. What's it doing?
Would that be a shower?
Shower.
There's a moderate rain shower. Okay, so you would say, oh, it's raining out. And yes, that's the way people talk. But technically, oh, there's a rain shower occurring. So if I'm working at an airport with an observation, this is a rain shower. Probably, I'm saying the visibility is about a mile, maybe 1.5 miles. I would say it's a heavy rain shower. And when I'm doing visibility, and this is something you could do at home, you just find markers and you go, how far away is that? Google Maps is cool because you can actually go, here's my house and here's that antenna, and it's exactly 2 miles away. When we're at COD, I look out the window. If I can see the radio tower, that's a half mile visibility. So I know that the snow is not falling heavy. If I can't see the tower because it's snowing, I know I've got heavy snow. So I look around, and they do that at airports. They have visibility markers. That building is this far away, that tree is that far away. And then you just look. And if I can't see it, I know the visibility. Okay. So that's how that goes. All right. So any questions on the pressure? On doing that. Okay. The next thing is when I draw lines like this. And that is telling me the wind direction. Now write this down, folks. Ready? Wind is named from where it came. Wind is named from where it came. So this line is pointing to the direction that the wind is coming from. In other words, you could think of it as being I'll just do it this way. You can think of it as being this way. You can think of it as being an arrow like that. Oops. No, that's not an arrow. So what direction is the wind in this case?
Southeast.
That's a southeast wind, right? It's coming from the southeast. Now, you don't draw the arrow. That's just what you have to kind of picture in your head. So that's a southeast wind. What would this be? What's that?
A northeastern one?
Yeah, and you could say northeast. That would be fine, but do you agree that's not really northeast? It's more what?
North.
Just north?
I'd probably say northeast, right? So typically you're going to go 8 directions: north, east, west, south, northeast, southeast, northwest, southwest, right? But reality is you'd probably want to be more specific and say that's a northeast wind. So that's where that terminology comes from. On a test, I'm only going to ask you the 8 and not the ones in between. But a northeast versus an east-northeast is more easterly. And that's how that works. Does that make sense to you guys?
Yeah.
Okay. So at the end of these things, though, then they put on here lines. And what do you know about these lines? What do the lines tell you?
Those are wind speed.
Those are wind speed. And each long line is how much? I think your book gives you like a range. It's so much easier if you just go, that's around 10. Each long line is 10. Each short line is 5. So how fast are these? What are these winds in this example?
15.
15 knots from the southeast. By the way, we are going to be using a knot, which stands for nautical mile per hour. So 1 knot is equal to 1.15 regular mph. Miles per hour. Do you know what you call, how many feet in a mile?
Isn't it like 5,000 something?
5,280.
5,280. That's how many feet in a mile. And what kind of a mile do we call that? Do you know what you call a mile that's 5,280 feet?
Kilometer.
No, there's a kilometer's a kilometer. Kilometer is about 0.61 miles or 0.62 miles. What do you call a mile that's got 5,280 feet?
Aaron says statute.
That is correct. Statute. Oops, statute mile. So 5,200 feet is what we call a statute mile. Now, most people don't use that term, but when we think miles, that's what we're talking about, are statute miles. A knot, well, let me do it this way. A knot is a statute mile. Do you know what a knot is called? It's called a nautical mile. So a nautical mile per hour, which is a 60th of a degree of latitude. That's how it works down. You have 60 degrees of latitude, or I'm sorry, 1 degree of latitude, 60 nautical miles. We break it down into 60ths. It's like a clock. And in meteorology, we just use nautical miles, and we've used knots for a long time. By the way, somebody once told me, and I didn't know this, I had learned this from, I think, my students. Do you know where the term knot comes from?
It's the sailors used to throw a rope with certain knots in them, and however many knots would go past the boat is what they measured by.
Yeah, they threw a big rope, like an anchor or something, and there were knots in the rope, and they knew that they would count like in 15 seconds how many knots. They knew how fast they were going, so that's where that came from. So you'd actually measure the knots, which I think is really cool. How did you know that, Shannon?
Well, it's something I randomly knew, so.
Just random knowledge, still more fun than not random knowledge. Okay, now if there's a triangle, oops, where am I? Oh, I have to do this. If there's a triangle, what does that mean? If I put a little triangle on here. The answer, how much is a triangle worth?
50.
50 knots. So you add them together, 50 knots is not going to happen on the surface very often, although in hurricanes and really intense storms, you could get those. Here's one. What would this one be if this was the wind? Hold on. How fast are the winds? First of all, what's the direction? What direction are the winds in this example?
Southwest.
Southwest. And how fast?
5 knots.
Is it 5 knots or 10 knots? Is that, how do you know if that's long or short if it's the only one on there? See, Abby, this is
Very long.
again, as a pilot, you need to read your maps, right? The answer is this must be 10 knots, because if it were 5 knots, this little guy here would go not at the end. So if you see it and it's at the end, it must be 10. If it's only there, it's 5. Okay, so the 5 knots is never at the end. This way, if you're scribbling, if you're drawing it by hand, you'll never miss that. Okay, so that's wind. To the right, you will put something in here like this. And I'll give an example here. So what would that mean? What's to the right of the station model?
Pressure tendency, I think.
Pressure tendency. Okay, so let's do this. Oops. Pressure tendency is a 3-hour pressure change. That's a really important word that you need to make sure you know. What is the when they say what is the tendency, like you use it commonly, like what are you tending to do? It's kind of telling you something over time. But when I say pressure tendency, definitely it's a 3-hour pressure change. So in the example we have here, what are we saying? What has the pressure done in the last 3 hours?
It's gone down.
It's gone down. The negative sign, if it went up, I would put a positive sign. So in this case, the positive or the negative sign will always be there. This is, it's gone down. By how much? You've only got 2 digits there. So you think it's gone down 2 millibars? Notice we're measuring our pressure in tenths of millibars. So this should be tenths of millibars as well. And so the answer is that has gone down 0.2 millibars in the last 3 hours. So what was the pressure 3 hours ago?
Bars.
How much?
1001.6 millibars.
1001.6 millibars. You just, if you went down 3.2 millibars in 3 hours, you add 0.2 millibars to 1001.4. Okay, now next to it, you are going to also put a little symbol for what has the tendency, what has the pressure done. So if it did something like this, I would say the pressure rose and then leveled off. So that's a possibility. Or it could be this way. It went down and it started coming back up. Or actually, you'd probably see it more like this. That's, by the way, this is called a check tendency. You should know that check mark is a check tendency, means the pressure went down and now it's coming back up. Okay. To the lower right is a place for a symbol. So I'm going to put over here, I just, for the sake of simplicity, I'm just going to type in weather symbol. Like we saw the current weather, but this is past weather. Okay. Oops, doesn't come up, but it says past weather. You understand that WX is an abbreviation for weather. I hope you figured that out. Okay, so we have past weather symbol. So that's how you read it. That's how you decode a station model. And that's what I'm going to require you to do. So let's do, how are we going to get rid of this whole thing? Let's just undo everything. And I'll give you, actually, it's one of my favorite observations. I wish I had my Epic pen. Oh, geez. Imagine that I drew 4 of those. I'm not going to draw that. And then over here, I have and over here, I have Man, this is so much slower without my pen. Sorry, guys. Next week, I'll have it back. I'm going to buy a new one. Oops. Brush. That's a really horrible thing. Hold on, that's and then this one. This actually happened a while back, 2011. It's very similar to this. Gosh darn it. Man, I miss my epic pen. Why did you leave me? This is terrible drawing. Aaron, I'm drawing as bad as you are. There. That's horrible drawing. What's the wind direction?
Southwest.
Southwest.
No, not southwest.
Northeast.
Northeast. Remember, those are the feathers of an arrow. So that's the arrow's pointing to the southwest. It's coming from the northeast.
Gotcha.
What's the current temperature?
24.
24.
What's the dew point?
24.
What would the current weather be?
Fog. Or snow.
Heavy snow.
Heavy snow.
It'd be heavy snow. Oh, by the way, I'm missing one other thing over here. What's the past weather? What is that?
Thunderstorm.
Thunder.
We actually had this in the Groundhog's Day blizzard. What's the visibility?
1/16 of a mile.
16th of a mile, right? Temperature 24, dew point 24. That means the relative humidity is almost 100%. We have heavy snow, 16th of a mile visibility with winds at 35 knots. The sky is obscured, right? You couldn't see the clouds because it's snowing so hard. What is the weather? What is the pressure?
998 millibars.
Let's say that again.
Would it be 998.9 millibars?
998.9 millibars. What's the tendency?
Negative tendency.
Well, it's negative. How much? How much did the pressure go down?
By 1.8.
1.8
millibars.
millibars. And then it was steady, and then it started to decrease. So that would be a station up. And I like this. I would do more if I had my pen. I could do it fast, but that took a lot of annoying time. So, but do you all understand how to do this? I will give you this on a test, and you just have to decode it. Does that make some sense to you guys?
Mm-hmm.
Are we good with that? Isaac, you're okay?
Yeah.
Here I'm thinking Tim's going to be showing up late, and I marked him absent, present, and I have to go mark him absent. So don't know where he is today. Okay, so we're back to the last of the material. I think we've done all the other things of the atmosphere, and we've talked about meteors. So I just want to talk a little bit about another type of hydrometeor, and one of them is frozen sea spray. So I'm going to show you frozen sea spray, and I'm Googling, and I'm going to do some images of sea spray, because when you have big waves coming off of oceans like this, right? See this over here? You get a sea spray. Well, when the temperatures start to drop below freezing and you get these big waves crashing, you actually coat things with ice like this. Look at this. Can you imagine parking there? I mean, how the hell would you get this off? And you've got big ships getting full of this type of ice from sea spray. I just thought that's kind of cool. Have you ever seen, what do they call it? An ice tsunami. You guys ever heard of this?
Hmm.
Oh, I've seen
Yeah,
videos. of those.
isn't it due to the pressure of the freezing ice with the water and it can't stop or something?
Yeah, the winds are moving it with the currents and the waves, and the ice is just being carried with it. And it comes into, I guess some of them ice shoved. Ice tsunami is kind of a fun name. It's not really tsunami, but it does damage to people's houses because that ice just keeps coming. So let's see if I can find. This thing's always in my way. Let me go back here and find the video of that. Let's see, Minnesota. There. Let's check the phone.
Nikki, it's really pushing in.
So it's just all this ice coming on shore from Lake Superior.
Oh, it stopped. It's not gonna stop though. What? How is it doing this? The water's moving. The lake opened up, see? So the water with the wind is pushing, the water's pushing all this up here.
You're actually setting up a pressure gradient in the ice
No, I'm gonna take
that's
it out.
moving the
Sounds
ice.
like a train. Last night it felt like a tornado going through.
Let's skip ahead a little bit. You hear that noise?
I wonder how they would stop it. Definitely some dust straight shot in. Nikki, it just busted through a door over here. All the way through, the door's caving.
So I think that's kind of cool. Anyway, so that's some stuff that happens with ice. Now, most of the like rain and snow and hail. How about if I did hail? How about if I did hailstorm? I don't know. You want to watch this? I think I've seen this one's okay. Not the greatest, but it's not bad.
Holy shit, man.
Some good sized hailstones in that, bouncing around. Yeah, I'm not going to show you any more of that, but you get the idea. These are all hydrometeors. Now, lithometeors, if we have some big dust storms, there's a name for a dust storm. Anybody know what it is? Lena, do you remember what it was, or Sam?
Yeah, I'm thinking of it.
I think I know of it.
What's the word?
The haboob.
Haboob.
Yeah.
So if I go to Haboob from Phoenix, let's just look at this one. So it's called a haboob. That's a Middle Eastern name for dust storm or sandstorm. So here's a time lapse of this. It's an outflow from a thunderstorm, but this would be a lithometeor of blowing dust, or a thunderstorm with dust at the time. Look at how much dust comes in there. Now watch how dark it'll get when it comes over. Oh,
That's scary.
that's not a good one for the darkness.
And can't
here.
you get like lightning in those too because of the sand particles?
Yeah,
rubbing
you
together?
certainly can. So that was a big one. Did you guys ever watch the movie The Mummy?
Yeah.
What I liked about that movie is they had this really cool dust storm. And the very first time I watched the movie, I was like, wow, that is a really great, they did great special effects. It looks so real. Do you know why it looks so real?
Israel.
It was real. They filmed that scene in an actual haboob going on in the Middle East. And I was like, well, no wonder it looks so good, because I was like, how do you even fake that? It was fantastic. So if you ever watch that movie, you'll see a real good dust storm. So those would be lithometeors, okay? Now, the ones that we want to talk about are photometeor. Photo meaning light. So the first thing is we look at rainbows. Rainbows are going to be obviously beautiful. Now, how many colors in a rainbow? What's the typical way that we...
Seven.
Seven. And what's the guy's name that we pretend?
Roy G. Biv.
Roy G. Biv. Red, orange, yellow, green, blue, indigo, violet. And when we look at a double rainbow, it goes red to violet this way, and then the reflection one goes opposite. So they're going to be reflective right on the outside, inside here. But there is something called a supernumerary rainbow, which is an amazing thing, because then the greens to violets to the indigos start repeating themselves. This is called a supernumerary rainbow. I'm not going to test you on that. Has anybody ever seen one of these?
No, just double.
I think I saw one this past summer. I'm gonna go through my camera roll after this. I feel like I
That
saw
would be
one.
cool, Lena. Send that if you've got that. I've seen like 2 or 3 in my life, so they're not that common, but they're pretty cool. And you look at them and like, wow, that looks really cool. So those are those really cool rainbows. Now, other than that, we also have something called halo. Okay, and when you look at how light refracts around the sun, this is usually through cirrus clouds, which are coming through ice, but you get the big ring that's known as a halo. But there's a whole lot more to these things. These guys over here on the side are called sundogs, or more specifically, parhelia. So ready to spell this? Parhelion. That's singular, or IA if it's plural. Parhelion or parhelia. You get these patches of rainbow. You can also see them as different. There's names for all of these features of light that go around the sun. It's pretty cool. But the sundogs are cool. So when I look at sundogs, you will see these sundogs a lot. And around here, this is often what you'll see it as, just a patch of rainbow in the sky. So I think those are fun to see. Have you ever seen those before?
Mm-hmm.
They're just little specks of rainbow. And here you can see where they are. The sun's usually in the middle, and then they'll see it over here and over here. But you can actually see the arcs of light, and you don't always see these other arcs of light. You'll just see the patch of rainbow. Now, this arc of light coming right out of the sun is, anybody know what that's called?
A light pillar.
A light pillar or a sun pillar. Wow, you are just getting them. So here's some examples of sun pillars. The other day, what was it? Saturday night. Remember how it got clear and it got really cold after the snow? There was a sun pillar starting. It wasn't a really great one, but it was pretty decent. I think if you see a cool sun pillar like that, you'd remember
You should
this.
look up the night light pillars, because when the weather atmosphere is really cold, the ice crystals form. It creates like multiple of them.
Night light pillars coming. Oh,
I've seen a lot of sun pillars.
that's coming. Okay, so this is upward. Oh, that's really cool. This is lights coming from the ground.
Mhm.
My favorite thing that I saw, and we didn't know what it was. We saw this patch of light extending straight up near a town. And we're like, what is that light? And people go, well, maybe it's a train. I'm like, no, it's not a train. Well, and we're thinking about it. And I'm like, there was hail falling and the light from the town was reflecting off the hailstones. And it had this huge up beam of light. And then we're like, oh my God, that's really close. We got to get the hell out. We started hearing smashing on the roofs, and it was about a mile away getting hit by baseballs. So we got the hell out of there and came back later, and we were getting 2.5 to 3.5 inch hailstones on the ground. It was pretty awesome. In addition to that, we also have something known as, and I've never seen this, the green flash.
I really want to see one of these.
I'd like to see a green flash which turns green, and it flashes. It only lasts for like a second.
It's so cool. Then Sleeping Bear Dunes, on top of the dunes in Michigan, that happens. I've seen it before.
Have you really?
Yeah, it's so cool.
You suck. I've never been able to see that. So that's called the sun flash. We've got sun pillars. We've got all those sun dogs. And I guess that's it. I think that's all of them. So those are photometeors. Now the last one would be electrometeors, electricity. These are, remember, these are observed in the atmosphere, and there's electricity. So when you have plasma coming off the sun, which are charged particles flying through space in the solar wind, it interacts with the ionosphere and you get the auroras. So if I look at Aurora Borealis, for instance, phenomenal stuff, right? How many of you have seen these things?
I have once when I was little. I don't remember it though.
Has anybody else seen them? They move quite a bit. So if I could show you a short video, here's 34. Sometimes they're green, sometimes they're purple, sometimes they're red. They're awesome. I'd love to see that. So let's take a look at what they actually look like in real life. So there's a lot of movement in them.
I think one of the planets, Jupiter or Neptune, something has like blue auroras or something, I think.
Say that again.
I think Neptune or Jupiter, another planet, has like blue auroras or something special.
It might be, depending on how that plasma is coming. But remember, the plasma is coming from the solar wind. It's like the Earth is like a comet. There's material that's illuminating, and that's called that. So what's the other great electrometeor? What's the more common electrometeor?
Lightning.
Lightning is a common electrometeor. So when we look at lightning, let's look at high speed video. I don't know if this is good, but maybe. Probably have to watch an advertisement. I hate people. No. So this is only 25 frames a second, which is not really high speed. Whose is this? Oh, 2,500. There you go. Oh, that's kind of cool. You're getting what's called a step leader as the air ionizes, and then it connects as the return stroke. So it makes a difference. Tim Samaras used to do this at 10,000 frames a second. So let's see if we can get 10,000 frames a second. This is not 10 trillion frames a second, I don't think. Let's see if I can find Samaris. Let's try this one. So you can see this is the column of air ionizing as it moves down from the cloud. When it connects, that's where you see the flash. So if you look at the relative brightness, we don't see the step leader. It's happening fast and it's very dim, but we see that return stroke, and that's what's pretty cool. Now, you guys want to look at something else that's kind of neat? Blue jets. You ever heard of these things called blue jets? I'm going to show you a little bit of I'll just show you a 3-minute clip of some really cool electrometeors.
Storm clouds have a whole nother world of flashing lights just above them. Above the storms, red jellyfish-shaped lights, blue streaks, and huge donut-shaped halos flash.
They're called transient luminous events, or TLEs.
The TLEs we see most often are called sprites, elves, and blue jets. But before we get any further with those, let's take a look at what lightning is. Lightning is caused by electrical charges in clouds. These electrical charges are created when ice, snow, and water droplets in thunderstorms collide at high speed. All of those collisions build up static electricity in the cloud, and the charges can be huge. If they separate, the lower part of the cloud becomes negatively charged, while the upper part of the cloud can be positively charged. The positive and negative charges cancel each other out by shooting electricity between them, and that electricity is lightning. When a lightning bolt strikes the ground, it can leave the top of the thunderstorm with some negative charge. This creates bursts of electromagnetic activity in the upper atmosphere. And it's believed that those bursts are TLEs, the sprites, the elves, and the blue jets.
SPRITE stands for stratospheric mesospheric perturbations resulting from intense thunderstorm electrification.
I did not know that.
Sprites start as a huge ball of red light with tendrils that stream down and turn purple, then blue.
ELVE stands for emissions of light in very low frequency perturbations due to electromagnetic pulse sources.
I think they're just making this
ELVE start out as a flash of light that ripples out into a flat disc of glowing red-purple light, kind of like a halo or a huge donut in the sky. Blue jets are blue, and blue jet stands for blue jets, no acronym here. They shoot up from the top of storm clouds in the shape of narrow blue cones, and they are fast. They reach speeds of hundreds of kilometers per second. And as they shoot up, they fan out and disappear. So the next time you're watching some crazy lightning, just imagine the colorful light show that could be happening just above those clouds.
Okay, you got to admit, that's kind of cool, isn't it?
I feel like this might be wrong, but I might have seen those before when I was a kid.
Well, I would. Where?
Well, I'm not sure what it was, but I remember it was after this like really big storm, and there was like these like blue streaks in the sky on the clouds. I don't know.
On the top of the clouds? Up?
No, it was underneath them.
Yeah, well, then that would. Sometimes what happens, Isaac, is that when you get the lightning, like we always say, lightning's really white, but it's, excuse me, as it's going through a lot of rain, you'll get that bluish tint.
Oh, okay.
So these are things that are shooting up. And the funny thing is, blue jets and sprites have only been discovered in the last 25 years. We didn't know they existed until 25 years ago.
Okay,
and they're the very first areas to study them. They were out in Colorado in the foothills, and they'd be overlooking an MCS, these big nighttime nocturnal thunderstorm complexes across Kansas. And so on perfect nights, you could actually see, and you'd see it really fast. And they're really quick, but now they have better photography, high-speed cameras where you can capture these things, and they've actually started researching this. But until I think it was like the late 90s, we didn't even know they existed. I've never heard of that. Now, there's something known as ball lightning, and there's people who talk about this. It probably has something to do with plasma discharge. People don't really know very much about it. But anyway, those are electrometeors. And I just thought you should know a little bit about that. Now, is there anything within Unit 1 that you don't know about? Or is there anything that we want to talk about? If you look through the worksheets, not the worksheets, but the if you look through the notes that I gave you online, everything there should be stuff that we've talked about. Now I do mention Boyle's law and Charles' law. You can look at that, but that's just the ideal gas law. Obviously, it's the thermodynamics that are going to be the hard part of this stuff, doing lapse rates. So the lab is going to be on it. Those are all things you need to know. You've got the lectures, they're all online. And so as of this moment, we are done with the material for test 1. And since I have you, I want to go a little bit into material of 2, and this will lead us into Thursday's lecture. Okay. What is due for Sunday night into Monday? Like, do we have outlines or the worksheets? What chapter is coming due?
I think the next one was 6, but you haven't said when that one is, so.
Okay, let me look at something with you guys. Class assignments. Chapter 6 is due. When is it due? The 21st. Okay, so what is chapter 6 in your book? Let's look through the questions here together. Yeah, okay, so this is kind of going into the next unit. Where we talk about fair weather cumulus clouds, we talk about environmental lapse rates. So if you have not done this unit prior to taking the test, that is okay. Although we do have some stuff about cumulus clouds and halos. Look at what kind of cloud forms halos, and the answer is cirrostratus. But you can kind of take a look at that. But you don't have to have done all of chapter 6 prior to the test. But I do want you to have this done for next week's class. So if you get it done on Monday rather than on Sunday, that's fine too. Depends on how much time you have to catch up. But I won't be penalizing you if you're a little bit late on that, okay? So all the other stuff, all the other chapters should be done up to that point. And that can be covered on the test as well. People ask me, what am I focusing on? I'm focusing in on my lectures. My lectures contain everything. If I don't talk about it in lecture, I'm not going to give you a test on it. Now, the other stuff may help you know what I'm saying, and there might be information from them, and you certainly can use that, but it's focused on my test. I also think, very importantly, I think it's important that you study before you attempt the test. Do the lecture as whenever you want to, because that'll help you study, because you can take as long time as you want, but actually study as though this was an in-class test, even though you have open notes. It seems to me that people who do the worst are people who are thinking, well, I'll just use my notes, and they don't do very well because they don't know the stuff. So study as though it's not open note, and then, oh God, it's open note, yay, take the test. So anything else? You know what? It's 3 o'clock. What time is it? It's 3 o'clock. It's 5 to 3. I'm going to go ahead and end this session here today, and that'll give you some chance to really get your work in place. And then on Thursday, we'll hit the road running with the next unit, which is on water vapor. So what I want you to do is I want you to make sure that you printed out the class notes. If you have a notebook, make sure you've accessed them. And all I'm going to ask you to do is for the next few minutes is just go look at some of the terms in there. Because I want you to know dew point and mixing ratio. Just read, give me 10 minutes to read through, and then everything else is focused on the test. Can you do that for me? And I'll give you that time instead of having class. Okay, I got another thunderstorm coming by, so it's exciting here. Any questions, comments? Everybody know what's coming due? All right, guys. So I'm assuming that all of you are going to get satisfactory grades. Doesn't mean that I know what your grade is, but you're doing the work, so we're going to be happy. Okay, and those of you who are here all the time, I'm going to do my best to help you through. Get your work done, and I'll talk to you guys on Thursday.
All right.
Okay, see you later.
Have a
Thank you. Have a good day.
Have a good day.